Question 9, the functions. All right, so we're given two functions. There's an unknown constant k in one of them, and we're told that given the range of a combined function, g f x is greater than or equal to 39, well, what's the value of k? If you're stuck, you may as well put function f into g and see what happens. So when we do that, the whole of the function f is going to go into g wherever we see the x. So it's 5, and we better open brackets because it's the whole function. 3x minus 2 squared plus k, close those brackets, minus 1. Now we can expand just the first layer and get 5 times 3x minus 2 squared plus 5 times k minus 1. And let's stop and pause, because if you look at that, having the brackets with the square on it indicates that this is a turning point form. And we know a few things about it, where what makes the bracket 0, the x value, is the x value of the turning point, which means that's going to be 2 on 3. And then if the brackets is 0, the remainder of the function gives you the y value of the turning point, which is just going to be 5k minus 1. And if we look at where the x squared would come from if we expanded it, 5 times 3x squared, that's going to be positive, so we know that it's a smiley quadratic, and the turning point is the minimum. Now we know the range for this function is greater than or equal to 39, which means the y value of the turning point for this function has to be at 39. In other words, 5k minus 1 equals 39, 5k equals 40, and k is 8. So for part B, we're using our value of k, and we have to work out the range, which are the valid y values, for the function. And this time g is going into f, so let's take g and put it into f, and let's make k 8. So g was just 5x minus 1. We put it in. We'll have a big square brackets of 3 times 5x minus 1 minus 2 plus the 8. All right, so that perfect square, the square brackets, is still telling you, hey, this is still turning point form. And whatever x value makes the bracket 0 is the x value of the turning point. And when that is 0, whatever's left over is the y value of the turning point, which means the y value of the turning point is 8. Now we can also see from the values that it is still a smiley quadratic, which means that if the turning point y value is at 8 and it's smiley, then the valid range is all the y values greater than or equal to 8. We're finished. All right, part C. Function h they've introduced is defined, we don't know what it is, for all real values such that the GHX is 35x plus 19. Find an expression for the inverse of g, and hence or otherwise find an expression for h. Alright, again, if we are stuck, let's just do what they tell us. And the inverse of g, let's make the x's the y's the x's, and we'll have x is 5y minus 1, which means that 5y is x plus 1 and y is x plus 1 divided by 5. That's our inverse, x plus 1 divided by 5. Now, let's consider something for a moment. If we have a function fx and we have some x value, which is a, if we put the a into the function, we're going to get out a y value. So we put in a, we get out a y. Now, if you take the inverse and you put the y value in, it's going to give you back the a. Now, since the y value is the function of a, we can put that in where the y is and say the inverse function of the function of a is just gives you back a. Like, you start at a, you go to the y, and then you take the y and you go back to the a. You don't need to have the a. We could have anything in there, and we could even have a function in there, which leads us to saying this: the hx function is equal to the inverse of g of the function of g of the hx function. And it's like, oh, all we have to do is take the GHX, which they told us is 35x plus 19, and put it into the inverse, and we have the function h. So if we do that, we get 35x plus 19 plus 1 divided by 5. We add the 19 and the 120 and divide both by 5. We get 7x plus 4, and that is the function h.